Okay, so here we go. The objective, if you see that at the top, says we want to be able to add and subtract radical expressions. Like radicals, and if you'll do me a favor, use whatever writing utensil you have, and let's circle this sentence below. Like radicals are radical expressions that have the same index and radicand. So, Chris, can you reread that sentence for me? Because this is really important.
Like radicals are radical expressions that have the same index and radicand.
Okay, and then Luke, what is a radicand? What is a radicand? It's the thing underneath the radical, okay? The thing underneath. So, look, if I have radical 2 plus 3 radical 2, that's implied to be a 1 in front. So 1 plus 3 is 4 radical 2. If I have cube root 7 minus 5 cube root 7, that's negative 4 cube root 7. If you put variables in, that doesn't matter as long as everything underneath is the same. The square root of 5xy plus 8 square root of 5xy is 9 square root of 5xy. So all you're doing is you treat the radical as a like term. So let's jump down to example 1. It says I have 3 square root 5x minus 2 square root 5x. So you can either put a 1 or not put the 1, but it's 1 square root 5x. What's wrong with letter B? Mia?
The x with the 6 is squared, like the other one is
The radicand.
The radicands aren't the same, okay? They're not like radicals, so I can't combine that.
Oh, wait. Okay.
Do you see that? It's a square root 7 and a square root 5.
So what I said was wrong.
It's okay.
That's fine.
All right, Josh, in letter C, what do you get if you combine these?
You get 4, the 3,
Cube root.
yeah, cube root, 7xy.
Nice. There you go. All right, I'm going to pause, and I want you to do D through G. If you can't do it, say can't combine. They have to be like radicals. All right, Delaney, what did you say for D?
Couldn't combine
You are correct. Why can't you?
because the radicals are the same.
Good job. One's a cube root, one's a square root. So they have to be like radicals, okay? All right, how about letter E? Cameron, what'd you say for that one?
7x square root xy.
You got it. 7x square root xy. All right, Jesse, what'd you say for F?
2 square root 3x squared.
Yes, except let's tidy that up. That's a fifth root, right? Maybe you can't see it real well. That's a fifth root, but yes. All right, how about letter G? Brooke, what'd you say there?
6 square root 3.
All right, so when there's no number in front, it's implied to be a 1. All right, when you're ready, we're going to flip, and today we're only going to get through example 2. That's as far as we're going to go. We're going to pause. I'm going to give you the homework, but then we're going to spend most of the period going over last night's homework, okay? So I wanted to just take my time with that. All right, when you have a sum or difference of radical expressions, you should simplify before you say you can't combine. So if you look at example 2, I want to add 3 radical 8 plus 5 radical 2. And initially you might say I can't do it. But what can you do with radical 8?
Simplify.
Yeah, simplify. Simplify is the factor tree. Okay, simplify is the factor tree. So let's do that. This is 2 times 4 and 2 times 2. The most common mistake that I've seen over the years is that students lose the number out front, the 3. Don't lose it. So look, I can pick a pair of 2's, but it's multiplied by the 3. So what's nice is we're going to practice 6.2 as we do 6.3. So look, here's my 3, and this becomes 2 square root 2. So that's 6 square root 2 plus 5 square root 2, and then that would be 11 square root 2. So before you say I can't combine, you need to see if you can simplify. So I'm going to pause, and I want you to simplify the square root of 12 using your factor tree. Simplify the square root of 75 using a factor tree, and see if any combination can be added or subtracted. You are not doing, I'm starting to pass out tonight's homework. You're not doing all of this. You're going to do 1 through 15. But I wanted to give you more time this period because I kind of gave you a lot this week. And I wanted to give you a little extra time. So on the worksheet, right at the top, you're doing tonight's homework. You're doing 1 through 15. Okay, you're just doing 1 through 15. But before you work on homework, I need to make sure you completed or turned in the coloring page or riddle. Most of you have. Make sure you did the spiral review for this week. I have a few who haven't completed it. So I want you to get those done before you work on tonight's homework. Alright, when I simplified, I got 2 square root 3 plus 5 square root 3, and then I have the minus square root 3. So George, what did you get as a final answer on this one?
6 square root 3.
Nice, okay? 2 plus 5 is 7, but this is the tricky part. There's no number in front, but it is implied a 1. Alright, so that finishes as far as I wanted to get today. So here's what I need you to do. I need you to take out